I'm Anusha. I'm a principal software engineer with AWS. I work with the messaging and streaming organization here. I started my software career with AWS working for Amazon S3, and then I moved over to messaging and streaming. Joining me today is Divya Sridhar, who is a senior product manager on our Amazon MSK service, which is our managed streaming for Apache Kafka offering. Before we dive into our session, I have a couple of questions to get to know you all a little bit better. How many of you run streaming applications using AWS today? OK, it's almost all of you. OK, in that case, how many of you have been using AWS streaming for at least a year? How about 3 years? How about 5 years? OK, nice. That's really nice because the way we've planned this session is to cater to both kinds of audiences who might be here today. One who's really familiar with the portfolio that AWS offers for streaming, who's already running streaming pipelines on AWS, and the other category who might be here to learn about what streaming is and how you can migrate some of your self-managed workflows to our fully managed offerings here at AWS. I want to take a quick moment to thank some of our customers who might be in the room today, who are powering your businesses on top of AWS. Thank you so much for helping fueling our innovation here. Let's start by talking about this thing called data. We all understand the value of data in today's world. Forrester published this report in 2016, and it's still very much valid today, by the way. And they call data a perishable resource. The insights that we derive from data have a shelf life associated with them. Now, what I found really interesting about this report was that 75% of the businesses that were interviewed said that untimely processing of data inhibited their business opportunities. So speed matters in today's age for success. For example, I would really want my bank to alert me about a fraud activity within minutes rather than after a week when I potentially can't do much about it. So, driven by this need for continuous business intelligence and near real-time analytics, streaming is picking up at a very rapid pace. How do you know when something is streaming data? And how do you differentiate it from bulk data? Well, streaming data is typically high volumes of data, continuously generated by thousands of sources simultaneously and in small sizes. We typically see in the order of kilobytes. Streaming data is widely used in almost all industries. So you're out there thinking, do I have a use case for streaming? I'm sure you most probably do. Some of the examples of streaming kinds of data that we see customers using on AWS are log files from servers, devices, applications, IoT devices, in-gaming player activity, data coming in from financial trading platforms, social media platforms, and so many more. When you have streaming data that is perfect for streaming, how do you use that data to set up a data streaming workflow on top of AWS? To make this a little easier to visualize, I'm going to talk about an example of a customer who modernized their application for real-time analytics on AWS. Nextdoor, which is an app or portal that neighborhoods across the world can take advantage of to stay connected to each other and share information with each other. Nextdoor originally had a batch processing workflow, which worked at a slow cadence. And it made it hard for the company to transform data into real-time personalization for their customers on the applications. So they decided to transform this into real-time analytics by using AWS. They wanted to take events like what data customers were looking at, how long were they looking at that data, what engagement channels customers were using, and transform that into real-time personalization. They started off their pipeline with an ingestion source. And for this, they used Kinesis data streams. They also set up a data policy to retain data for 24 hours so they can replay the data even after it was processed once. The next step was to actually run the real-time analytics on those events in Kinesis data streams. And for this, they used Kinesis Data Analytics, which is our fully managed service for Apache Flink. Once the insights were analyzed, they persisted it onto a data store. They used DynamoDB for this. Now, next door's use case ended here, but you can extend it further. You can take the insights that were persisted to this data store, like TDB or even S3, and you can run a quality engine like Amazon Athena or Amazon QuickSight to visualize your data for further investigation. As I talked about a little earlier, customers use AWS for a lot of streaming use cases, and here are some of them. Hopefully, these resonate with some of the business problems that you already solve using AWS streaming or you are looking to solve. One common theme that customers tell us is that building streaming applications and architecture on their own is a really challenging problem. You have to create clusters, you have to manage instances, and you have to scale them as your business is growing. And let's face it, scaling is a really hard problem for any engineers to manage, and it takes away the valuable time that you should be focusing to drive your business use case rather than having to manage infrastructure. To help you with this, we offer a number of different services in our AWS streaming portfolio. We have Kinesis data streams, Kinesis video streams, Kinesis Data Analytics, which is our managed service for Apache Flink. We have Kinesis Data Firehose, and Amazon MSK, which is managed streaming for Apache Kafka. In this session, we're primarily going to focus on the data streaming workflows, data streaming services, and talk about the new launches in those. Customers who run streaming applications on top of AWS constantly tell us that AWS offers one of the broadest and the deepest capabilities of streaming anywhere in the world. I want to spend a little bit of time talking about each service for those of you who might not be familiar with it. Let's start off with Kinesis Data Streams. KDS is a fully managed serverless offering on AWS that helps you ingest high volumes of data and makes it available for processing at low latencies. It stores data durably across 3 AWS availability zones and provides an availability SLA of 99.9% for you to deploy your mission-critical applications. When I think about streaming applications, I typically think about 2 characteristics. The first is that I want my data to be delivered to more than one consumer, so I can set up parallel processing pipelines to do different things with the same data coming in from the stream. With Kinesis Enhanced Fan-Out, you can set up to 20 different consumers that process your stream, and you can set up each consumer with its own read throughput, and we make sure to deliver data from your producer to the consumer within 70 milliseconds. The other characteristic of streaming that I look for is integrations. Oh, sure, your data is into AWS, but how do you manage to pull it along into the next set of your streaming workflows? With Kinesis, it's simple, and you can set up AWS integrations within just minutes. We offer integrations with a lot of AWS services like S3, DynamoDB, Amazon Redshift, Lambda, CloudWatch, and so many more. As an engineer, I love building on top of AWS because it is really smart about scaling. I don't want to be worrying about managing infrastructure and scaling, and I only want to pay for what I use. With Kinesis On Demand that we announced last year at reInvent, when you sign up with KDS, you get auto-scaling by default. It's also really easy for you to apply on demand to your existing streams with just one click with no downtime. Once your data is in Kinesis data streams, the next step is to use it to feed into your ETL workflows. For this, let's talk about Data Firehose. Firehose makes it easy for you to capture, transform, and load massive volumes of streaming data from sources to destinations. We support a variety of destinations that customers typically look for: Amazon S3, Amazon Redshift, Amazon OpenSearch, Kinesis Data Analytics, even generic HTTP endpoints, and service providers that you might want, like Datadog, New Relic, MongoDB, and Splunk, enabling near real-time analytics and insights for your business. Firehose is serverless, and you only pay for the volume of data that you ingest. With Firehose, you can not just load, but also transform your data. Say you want to set up a Firehose to write to S3, and you want to compress your data before you write it so you can save costs on network and storage. It's easy to do with Firehose by just attaching a Lambda function for your compression, And every single record that's flowing through your fire hose will now start getting compressed. Similar to next door, once you ingest data into data streams, you might want to run real-time analytics on top of it. To do this, I'm going to talk about Kinesis data analytics for managed Apache Flink. Let's spend a minute to understand what Apache Flink is. Flink is an open source framework and distributed engine for processing real-time data streams. It supports stateful computations, it performs analytics at in-memory speeds at any scale, and it processes bounded and unbounded streams of data. Similar to the next door example, you can use Flink to perform real-time analytics on events that is generated by your customers or your applications. Data streaming and analytics can be really powerful when you can not just use it for real-time analytics, but you can correlate real-time analytics to historical data to create trends. Think about use cases like fraud detection or anomaly detection. Apache Flink is a great resource for you to help with this as well. With Kinesis Data Analytics, we offer a fully managed service to run Apache Flink, and you can interact with streaming data in real time using integrated Flink applications. We offer pre-built operators and analytics capabilities that enable you to build an Apache Flink app within just hours instead of the typical months that it takes to build. We offer the ability to integrate with multiple AWS sources and destinations, and you can also bring in your own custom connectors like many of our customers do. I want to specifically call out KDA Studio, which is our fully managed offering for Apache Zeppelin. It allows for customers to inspect and visualize streaming data in a notebook-based experience, where you can run ad hoc queries to quickly inspect data streams and view results within just seconds. The topic of streaming would be incomplete if we don't talk about Apache Kafka. Apache Kafka is an open source distributed event processing platform for high-performance data pipelines, streaming analytics, and data integration. With Amazon MSK, we offer fully managed experience to run your Kafka workloads. You can easily transport your Kafka applications onto AWS with Amazon MSK, and we automate the server and the cluster management while providing durability and security for your data at AWS scale. Kafka with MSK is easy to use. You simply deploy your native applications and tools, and Kafka just works with no additional code changes required. Newer versions that are available in Apache Kafka are made available in MSK within just 7 days. And as customers, you can choose to upgrade to newer versions, which makes it really easy for you to pick and choose the bug fixes and the features that you want to move to. And once you pick the newer versions that you want MSK to upgrade you to, we automate the deployments of version upgrades on your running clusters to maintain the client I/O availability for customers who follow best practices. Finally, we take the wealth of knowledge that we have by running Apache Kafka at AWS scale, and we transform that into iterations and features that we contribute back to the open source community for the whole world to take advantage of. We're going to look at some of those recent launches in this session. I want to quickly highlight the different modes in which customers use Kafka today. The first is on-prem. The second is we see a lot of customers using self-managed Kafka on Amazon EC2. And last is the experience with Amazon MSK, which is our fully managed offering. You can see how with the fully managed version, you get to offload a lot of that heavy lifting involved in running your application to us here at AWS, so you get more time to focus on creating streaming applications and not managing your infrastructure. OK, the session that you've all been waiting for. What's new in streaming? We've organized this session into different themes that we typically hear from customers who talk to us about what they would like to see in streaming as we build iterations on top of our portfolio. I'm going to cover the first theme, and then I'll hand it over to Divya to walk us through the rest of the session. Let's talk about hands-off capacity management. As an engineer, the ideal world for me is a world where I don't have to manage infrastructure by hand. I'm sure it's the same for most of you. Capacity planning can become really challenging when you're operating dozens of workloads with different traffic patterns. And let's face it, as a customer, you're not just one customer. You have thousands or millions of customers who are your customers who have different traffic patterns, and that makes your traffic patterns differing too. And your businesses are exponentially growing. What seems like steady state traffic today might not be tomorrow. It can quickly change into an unpredictable workload or a highly variable workload. Customers have asked us for a default experience that enables them to get to market faster and reduce total cost of ownership while managing infrastructure. When I think about scaling, I typically think about scaling for two types of workloads, highly variable and unpredictable. Let's say you're a news media company. You might have different times of the day when your viewership is very high. Let's call them peaks. And certain types of the day when your viewership is not so high. Now, in order to make sure your business is available to support your peaks, you always need to scale for your peaks. Unpredictable workloads can be even more challenging to plan for. Let's say you have a breaking event in the middle of the year, and suddenly you have 2 times the number of customers that usually log in during your peak times. This is challenging because you not only need to plan to get the 2x capacity, but you need to get there ASAP so that your business continues to operate while customers are coming in. We saw how Kinesis data streams helps you with this problem with our on-demand offering we announced last year at re:Invent. Well, now you can do the same thing with our Amazon MSK service with our serverless offering that we've launched earlier this year. MSK Serverless is a new cluster type for Amazon MSK. You can run Apache Kafka without having to manage and scale cluster capacity. We automatically provision and scale your cluster while managing the partitions in your topic. As with every serverless offering, it is a throughput-based pricing model, and you only pay for what you use. We've made MSK Serverless to be fully compatible with Apache Kafka, and you can use any compatible client applications to produce and consume data. Additionally, this re:Invent, I'm really excited to tell you about 2 additional launches that we've added to the serverless portfolio. First, we've launched MSK Connect with MSK Serverless, where you can now move data in and out of MSK Serverless clusters using Connect with popular data sources and data sinks. Additionally, we have expanded the region availability for MSK Serverless. It's now available in 11 AWS regions for you to use. Now, some of you might be wondering, this is great, but when do I know how to pick between a provisioned offering and a serverless offering? Well, the way I think about it is, it really depends on how well you're able to forecast your workloads. Provisioned capacity is best for you if you have relatively predictable application traffic, if your application traffics are consistent, or if your ups and downs are more gradually happening. You can then reserve a certain portion of infrastructure, and you know exactly what you're going to pay for. The on-demand capacity mode is best for you when you have unknown workloads or unpredictable application traffic, and if you only want to pay exactly for what you use in those unpredictable scenarios. The on-demand pricing model at AWS is ideal for bursty, new, or unpredictable workloads whose traffic has to spike within seconds or minutes, and when under-provisioned capacity means impact to your business availability. Now I'd like to talk about another aspect of capacity management that our customers who use MSK have talked to us about. We see organizations increasingly adopting Apache Kafka and Amazon MSK to run their streaming applications. And they use it as a reliable buffer between their mission-critical applications to stream data. All the data that is stored on the Kafka clusters are processed typically within seconds, near real time. Apache Kafka supports a performance-optimized storage tier specifically to deliver this low latency on your reads and your writes. However, customers have told us that they sometimes want to retain data for a bit longer to plan for any failures, or sometimes they want to run their processing on older data to streamline their applications a bit better. Due to how tightly coupled Apache Kafka's compute is with storage, to expand your storage, you also have to expand compute. This is costly because you're now adding more compute that you don't really need to. Customers have found a workaround for this. What they do is they take the data that they want to retain, put it onto persistent storage out of the Kafka clusters, replicate the processing logic, and run it on their persistent storage. You can imagine how this adds a lot of operational overhead to engineers and a lot of application code that you need to write. Customers have asked us to solve this problem for them. And they've also told us that they don't need the low latency and high performance that the current Kafka storage tiers offers to them. Well, we have heard you, and we are very excited to announce the launch of MSK support for tiered storage. With tiered storage, you now get cost-efficient storage for longer-lived data in Apache Kafka. You can retain data for a short period of time in your performance-optimized tier, and then you can use tiered storage to automatically copy your data. You get to balance performance with your low costs. It has virtually unlimited data, so you don't have the need to manage and provision extra capacity or compute. The feature is easy to use. You can simply turn it on by enabling tiered storage configurations on your MSK clusters. Finally, my favorite part, we've designed tiered storage to be fully compatible with the APIs that you already use to retrieve data. And so you have no additional code changes required to use this feature. Now, these autoscaling features are great when you have an easier set of requirements on which you can monitor and understand when you need to scale your infrastructure or your capacity. Now, as an engineer, the top indicators that I look for to determine when I need to scale are CPU, memory, and disk usage. You might have other key performance indicators that you monitor to know when to scale. Customers who manage applications on AWS, especially in our managed open source portfolio like Kinesis Data Analytics for Apache Flink, have told us that having better visibility into these metrics will empower them much better to define thresholds that matter to them and to indicate to AWS when they would like to scale. And we, the engineering team at AWS, have built exactly that for you. Starting now, we are publishing 3 new container-level metrics on Amazon CloudWatch for CPU, memory, and disk usage for your Flink task managers. You can think of Flink's task managers as the worker nodes that actually perform the data processing for your Flink applications. With these metrics, you now have better visibility into your task managers to know exactly how to manage scaling. With these features for hands-off capacity management, it becomes one step easier for customers to manage less and offload a lot of their capacity management to us here at AWS so you can have business continuity with lesser engineering time invested in it. With that, I'm going to hand it off to Divya to talk about the rest of the themes, and we're going to be available off stage after the talk for Q&A. Thank you.
Can you all hear me okay? All right. Thank you so much, Anusha, for kicking us off today. The second theme that I want to talk to you about today is ease of use. We at AWS are constantly looking for ways to make it easier for you to use our services. The same holds true for our streaming portfolio of services as well. Today, I want to talk to you about 3 new capabilities within our streaming services that help drive ease of use. Now, improvements in usability can mean a number of things. It could mean better observability, as an example. Let's talk about Kinesis data streams, which is one of our streaming services that helps you stream data. With Kinesis data streams, say, for example, you needed to have better observability of the streams within the service. Say, if you wanted to look into a data record to understand what the data structure was, or perform some ad hoc querying on specific records in order to do some ad hoc troubleshooting or testing for quality assurance purposes. Typically, you would have to rely on your client to programmatically connect to your Kinesis data stream in order to achieve this outcome. We've heard from you and a number of other customers that you're looking for that easy button so that you can quickly visualize and observe the data within your streams without having to rely on clients. So I'm happy to tell you that the Kinesis data streams now supports the data viewer in the AWS Management Console. So you can leverage the convenience of the AWS Management Console to quickly visualize the data within your streams and understand its structure when you're dealing with unfamiliar data. You can also run queries on specific records to troubleshoot or do data debugging. This feature is now available in all AWS regions where Kinesis data streams is supported. Improvements in usability could also mean improved availability. Kinesis Data Analytics, which is our managed offering for Apache Flink, helps you maintain highly available Apache Flink applications. It also maintains application security and compliance while maintaining availability by performing periodic patching for the underlying infrastructure that runs your applications. KDA executes these maintenance activities at preset times that are determined by the servers, and this maintenance cycle is barely visible to customers. The application goes down just for a few seconds when the maintenance activity kicks off. Now, we've heard from some of you that when the maintenance happens, it may not be suitable in terms of the timing. Say, for example, you had a very business critical time in terms of the business hours and the maintenance activities kick in. You need your Flink applications to be highly available during this time of the day, and you didn't want the maintenance activity to happen at that time. We understood that this is a problem that we needed to solve to ensure highly available Flink applications while also maintaining security and compliance through patching. So I'm happy to share that Kinesis Data Analytics now supports customized maintenance windows where you can tell us the time of the day when maintenance needs to happen. With this, we will ensure that maintenance kicks off during the times of the day that is more suitable for your business needs, and you maintain business continuity while achieving high availability and meeting security goals and compliance. Improvements in usability could also mean improved performance. With Kinesis Data Analytics, you can turn on logging to better observe your Flink applications. When logging is turned on, we previously saw that application processing was a little bit slower, and this was because application processing and log processing was happening synchronously. As a managed offering, KDA saw this as an opportunity to improve the customer experience and invested time in decoupling log processing from application processing. So now, when you're using Kinesis Data Analytics to run your managed Flink applications, you get improved performance 5x more when you have logging turned on for your applications. So you get the great combination of improved performance with better observability through logging. With all these features, we make it a little bit more easier for you to use our streaming portfolio of services and drive ease of use. The third theme that we want to talk to you about today is AWS Integrations. In the streaming space, integrations is really key because, as Anusha was talking about earlier, when you think about your streaming workflow or pipeline, streaming services like Kinesis Data Streams, or Amazon MSK are merely components within your streaming workflow. You really need tight integrations between a number of databases or data systems to move data in and out of your streaming services, and integrations play a pivotal role in making this experience easier. In the context of streaming, what customers ask us is for an easy way to move data in and out of our streaming services in a very low-code or no-code fashion, and without the need to manage any of the underlying infrastructure that is required to power this data movement. So today, I want to share with you some new capabilities that we've launched in this area that makes it easier for you to move data in and out of our streaming services. Earlier, Anusha talked about the Kinesis Data Firehose service, which is our streaming ETL service that helps you to move streaming data very easily. It supports a number of sources in terms of streaming ingestion, and it enables you to transform this data through its built-in transformation capabilities and load streaming data to a number of destinations. This is an area that Kinesis Data Firehose will continue to invest in to ensure that you have the best experience in choosing AWS for your streaming workloads. So I'm happy to share that Kinesis Data Firehose now supports VPC flow logs as a new source for streaming data, and also the newly launched OpenSearch serverless offering as a destination for loading streaming data. Another offering that we have that enables easy data movement is Amazon MSK Connect. Amazon MSK Connect is a feature of Amazon MSK that helps you to run managed connectors to easily move data from popular sources and destinations onto Amazon MSK and out of Amazon MSK. Amazon MSK Connect is built on top of the Apache Kafka Connect framework, which is fully compatible with Apache Kafka and facilitates this easy data movement. Amazon MSK Connect works with a number of popular sources and destinations such as Amazon MS3, S3, Amazon OpenSearch, and much more. When we launched Amazon MSK Connect last year, we had a requirement that in order for you to connect your systems with Amazon MSK Connect, these systems needed to have host names that are publicly resolvable over the internet. As we had a number of you use our feature, and we heard a lot of feedback from some of you that this may not always meet your security goals. And this is because you had your own corporate security requirements that needed you to keep these systems within your own VPCs inaccessible to the internet. So we heard you, and I'm happy to share that Amazon MSK Connect now supports private DNS. And with this feature, you can have your systems in your VPCs, and the connectors will use DNS servers in your own VPCs to resolve custom private host names and enable you to use these systems easily with Amazon MSK Connect and essentially move data really easily in and out of Amazon MSK. This feature also enables you to use Amazon MSK Connect with MSK Serverless, as Anusha talked about earlier. Another popular destination for streaming data is Amazon Redshift. With Redshift, you can use it to power some real-time analytics use cases by ingesting your streaming data onto Amazon Redshift. A couple of examples that I can quote is, say, from the gaming space, you could analyze data coming in from gamers in real time to improve the gaming experience. In the online advertising space, you could analyze clickstream data coming in from consumers to understand behaviors and patterns and improve your marketing campaigns in your real time. So the key here is the need to have the ability to move your data from your streaming sources to Amazon Redshift with high throughput and low latency to be able to achieve those real-time analytics use cases. Now, we have solutions out there today that power this use case. So for example, you could use Kinesis Data Firehose to move data from Kinesis data streams onto Amazon S3 and then to Amazon Redshift. This is really great if you needed to harness the power of Firehose and use its transformation capabilities to massage your data before you need to finally get it to Redshift. But this may not be ideal if you needed to have those real-time insights because of the multiple hops and the additional latencies. So to solve this problem, I'm happy to share that the Amazon Redshift is now natively integrated with both Kinesis data streams and Amazon MSK, allowing you to achieve really high throughputs and low latencies and stream and use the power of Redshift to get real-time insights into your streaming data. The feature is really easy to use, and you don't have to manage any of the underlying infrastructure that is required to power this data movement. Getting started is also very easy in the sense that you could start analyzing your streaming records using familiar tools like SQL and run queries on top of materialized views on Redshift without the need to learn any new languages or skills. All these features put together offer a richer set of integrations between streaming services in AWS and help you to easily achieve your outcomes with AWS streaming. The last theme that I want to talk to you about today is our work with the open source community. Within our streaming portfolio of services, we have two offerings that are managed offerings on top of open source software. We have the Kinesis Data Analytics, which is our managed offering for Apache Flink, and we have the Amazon MSK, which is the managed offering for Apache Kafka. In both these areas, we work really closely with the open source community to build new features, contribute bug fixes, to make sure that not only our customers who use our services benefit from our work, but also the broader open source community. Today, I want to share with you a recent example of how the Kinesis Data Analytics team worked really closely with the Apache Flink community to drive innovation on behalf of customers. I'm happy to share that Kinesis Data Analytics now supports the latest Apache Flink version 1.15.2. The service played a pivotal role in driving the release of this version and contributed a very important feature called the Asynchronous Sync framework to this version release. In fact, AWS was one of the top contributors to Apache Flink for the last few months leading up to this new version release. Now let's talk about this Asynchronous Sync feature. Earlier, we were talking about facilitating easy data movement. Syncs are a similar concept in Apache Flink, where you could get data in and out of Apache Flink. Now, if those syncs are natively supported by Apache Flink, then that's great, and you can easily connect those systems and use the power of Flink to drive your analytical use cases. But what if the sync is not supported natively? In those scenarios, you would have to build a custom sync. And building a custom sync is a pretty time-consuming and complex process where you'll have to design and account for a number of things, such as batch processing, checkpointing, accounting for back pressure, retries, and so on and so forth. So with the Asynchronous Sync feature, you can now build a custom sync in under 20 minutes. The open source community is already benefiting from this feature and is working on building custom syncs for Amazon DynamoDB and Redis streams. In addition to the Asynchronous Sync feature, the latest Flink release includes a number of improvements, including improvements to the Kinesis Data Streams connector, the Kinesis Data Firehose connector, Python user-defined functions, Flink SQL, and much more. So with all these features that we've launched over the past few months, you really get the benefits of offloading capacity management, improved availability, observability, and better performance, and tighter integrations across our AWS portfolio of services to really harness the power of our streaming capabilities to drive your streaming use cases. Before I wrap up this session, I also want to leave you with some thoughts about what's next in AWS streaming. As we hear from you and a number of other customers about how you want to use our streaming portfolio of services to drive your business use cases, we distill your asks into some key themes that really resonate. We hear from you that you're looking for more scalability so that you can continue to rely on us as your business grows with AWS streaming. We also hear from you that you're looking for better price performance so that you can maximize the value of your investments in the streaming portfolio of services at AWS. And we also hear from you that you're looking for more out-of-the-box support for operations, scalability, ease of use, and resiliency at scale so that you get the best-in-class experience in running your streaming workloads with us. As we continue to evolve our streaming portfolio of services, we will invest in these areas and more so that you get the benefits of the breadth and the depth of our streaming capabilities to power your mission-critical use cases. As I wrap up, I will leave you with some links to resources so that you can go and check out our product pages to learn more about our streaming services. Thank you so much for your time today, and I really hope you all had a great reInvent. Anusha and I will be available off stage to help answer any questions that you might have. Thank you.